So today we are going to discuss follow sets. Recall that last time we talked about constructing LL1 parsing tables and we discussed first sets. Also recall that we discussed how first sets and follow sets can help in deciding which production to use based on one look ahead. So follow sets. We define the follow set of a non-terminal x, follow x, as the set of all tokens t such that the start symbol can derive using one or more productions beta, capital X, small t, delta, right? So this basically means that it can derive some string of terminals and non-terminals such that small t follows capital X. And if that happens, then we would say that small t belongs to follow of x. Now, this is the definition of follow x, and here is some intuition on how to compute follow x. Now consider a production x produces a, b in your grammar. Then notice that if n something belongs to first of b, then it would also belong to follow of a, because I can always, from x producing ab, I can start producing, I can start deriving from b, and if small t appears in first of capital B, then small t would be following a. There's one exception to this. If capital B derives epsilon, which is the empty string, then we won't consider epsilon to belong to follow of x or follow of a, because unlike first sets where either a token or the epsilon character symbol could belong to first of x, and we define what does it mean for epsilon to belong to first of some non-terminal. Follow of x cannot contain the epsilon symbol. Follow of x must be some token. So if there's a production like x produces ab, then first of b minus epsilon, so discarding epsilon, is a subset of follow of a. So anything that is in first of b except epsilon can be safely added to follow of a, because anything that can be produced as the first character of b can follow a in some production, in some derivation of x. Also notice that if something can follow capital X, so let's say something can follow capital X here, then it can also follow capital B, right? Because if something can follow capital X starting from S, then I can always derive AB from X, and then small t would start following B, right? So in other words, follow of X should be a subset of follow of B. So just to see this more clearly, if something follows X, then basically means that there is a derivation of this form. S derives alpha, capital X, small t, beta. And I can always now derive from this alpha, a, b, t, beta. And so you can see that there exists a derivation from S, capital S, such that small t follows capital B, right? In fact, that's true. So anything that follows capital X will also follow capital B. So that's what this rule says. Follow X is a subset of follow B. Right, so anything that's in follow X can also be safely added to follow B if there exists a production of the form X produces AB. Now, also there is another interesting case. What if capital B could produce epsilon? If capital B could produce epsilon, then anything that is in follow X is also in follow A, right? So notice that if capital B can produce epsilon, then this can produce alpha, A. Now capital B will collapse into epsilon and t, beta, and now t is following A. So here's our third rule. If capital B can derive epsilon, which is the empty string, then follow X is a subset of follow A. So anything that's in follow X can be added to follow A. And how do we know whether capital B can produce epsilon or not? Recall that capital B can produce epsilon if and only if epsilon belongs to first of capital B. this is by definition of the first set. Epsilon belongs to first of B if and only if B can produce epsilon or B can derive epsilon. So these are intuitively these are the rules that we will use inductively to compute follow of X. Here is the algorithm. Once again, just like we did for the first set, we are going to define a set of rules, and we are going to keep applying these rules until all these rules are satisfied. So when I say keep applying the rules, we are going to keep increasing the size of the follow sets until all these rules become satisfied. And when these rules are all these rules are satisfied, we have reached our solution, and that's the solution of the follow sets for all the non-terminals. So here's the first rule. For each production of the form A produces alpha X beta, which basically means any production in which capital X appears in the RHS, and capital X being a non-terminal, then first of beta minus epsilon is a subset of follow X. So anything that can appear as the first token of beta would be considered to follow capital X. And this is something that we already seen using an example in the previous slide. Similarly, for each production A producing alpha capital X beta, if epsilon belongs to first of beta, so if epsilon belongs to first of beta, which basically means beta can reduce to the empty string, or beta is empty, which means that this production was really just A produces alpha X, then follow A is a subset of follow X. Now this is also easy to see. Either there was no beta or beta can reduce to epsilon, in which case anything that follows A can also follow X, because I can always derive alpha X from A. And once I do that, then anything that was following A is now also following X. All right. So these are the two rules. For any first of beta minus epsilon is a subset of follow X, and follow A is a subset of follow X if beta can produce epsilon, can derive epsilon. All right. So let's look at an example to see how follow sets may be constructed thus. So once again, we are going to keep applying these rules and adding to the follow set until we reach a fixed point. Initially, all the follow sets are initialized to empty. So our first rule is we want to construct follow E, and the production that I'm looking at is this one. S produces E dollar. And using the first rule, I can see that the first character in dollar is dollar, and that should be a part of follow E, because it can follow E. And so follow E is just the singleton set dollar character at this point. Now I can also look at other occurrences of E in this grammar, and I find another occurrence of E here where T is producing a parenthesized version of E. And notice that in this case, the terminal that is following E, the token that is following E, is the closed parenthesis or the right parenthesis. And so now I can also include the right parenthesis in follow E, and I update my follow E set to include both the dollar symbol, the dollar token, and the right parenthesis token. So far I have applied rule number 1 to populate follow E. Now let's look at X. What can follow X? So notice the first rule, E produces TX. So using rule number 2, anything that follows E will also follow X, right? So anything that is in follow E will also be in follow X, and that straight away gives us follow X. And so follow X is also must also contain at least everything that follows E, and that's dollar and right parentheses. Can we say something else about X? Well, we don't see X appearing anywhere else in the right hand side of the grammar. So let's stop here for X, and we'll revisit it again in the next iteration. Now let's look at follow T. So where all does T occur? So T occurs in production of E from, so E can produce TX. So anything that is in first of X will be, except epsilon, would be a part of follow of t. So one thing that's in the first of x is the plus token. So that's one thing. So follow of t is plus. But also notice that t is occurring on in another production. Y can produce star t. And using the second rule, we can say that anything that follows y also follows t. So far we don't know what follows y. So far the follow set of y is just empty. So we can't do much here. So we'll just leave follow t at plus. And then there's another application of the second rule that I can do. E produces tx. And notice that x can derive epsilon. In other words, epsilon belongs to first of x. I'm not showing the first sets here, but if we if we go back to our slides, we will be seeing that first epsilon belongs to first of x for this grammar. And so x can derive epsilon, which means that anything that is in follow of e is also in follow of t. And what is in follow of e? Dollar and right parentheses. And so we should add these two tokens to follow of t, and that's our next step. So we can we can expand follow of t to plus, dollar and right parentheses. Alright, now let's look at follow of y. So where all does y occur? Y occurs in this production of t. So t can produce int y, and straight away applying the second rule, we can say that anything that is in follow of t is also in follow of y, and so we get our follow set just from follow of t. We say follow of y, anything that is in follow of t should also be in follow of y. So plus, dollar and right parentheses just come from follow of t. Okay. And that's it. All right. So at this point, we can check again that all the rules are being satisfied. Once again, if we iterate over all the rules in the grammar, we'll be able to check that all the rules are being satisfied at this point. And because of this is our solution of follow sets.